Hello?
Your auntie.
Hello?
Hello.
Da.
Rini.
Ndio ndusange.
Nah.
Yeah, yeah, I think we can start with our lessons. So the last
Vavozivona zipost vavozivona dzantuni states ati ndizvondoguma ndovasendera navo vati
no ndidzanga kudzayunisa
ndokamba dzipost states no government.
Oh no ndasingodzivona.
Okay, next time mara ngariyobva ramurova nandikori ndovasendera.
No, unless if you sent and I did not see it, but I don't remember that you sent something. All right. Da. Oh yeah, exactly. Okay, no, I'll not try it. Let's quickly start with our lesson, of which is about the norms. So we have done, but it's something which I've done the last time. So I just want to remind you about this before we go to the next topic. So last week rokavara zinomo, rakavara dot product, rakavara na cross product. You remember, ne?
Yeah.
Yeah, those are the three important lessons we have covered. So now I just want to remind you about this because these are important. Before we go to the next chapters, we must know everything about these chapters. So now let's start with the norms. Which norms did we cover? We cover what is called one norm. And I've given you the formula for calculating the one norm. So usually norms are represented with symbols like this. So this is one norm of U. And then we also covered what is called two norm. Two norm of which you can write it in this form. And then the last one, we covered what is called the infinity. The infinity norm, which is given in that form. So you must remember all these norms. They are very important. The one norm, the two norm, and the infinity norm. Usually, we also have another one which is called Frobenius norm, but we are not doing the Frobenius norm. We are only doing these three norms. So now, number 4, we also covered. These are not the norms, but it's what is called the dot product. So you must know how to multiply the two vectors in this case, because we're now talking about the vectors. No, we are not longer talking about the matrix. We are talking about the vectors. And last time, I also gave you the definition of the vector. So we have a dot product, which you must be able to calculate. And then the other one is what is called the cross product. So we have what is called the cross product. So now musi ndiko todo rito focus nga manda.
Sorry.
Yeah.
Bomnyai.
Da.
Bomnyai.
Da.
Bomnyai bonotua.
Ah, you are on.
Da vakaya to show.
Ngari change.
At church nenda that the version total letter yo revise pala na pala mistake ye lecture abo discover or send or hedzi question na hedzi o dzi khakhulula ari dzi shume nga huswa.
Ndi hezwiḽa dze nda dzi khakhulula last time.
Yeah.
No. I'll not type.
Mara ndiko vona ngari yo chincha. Iko something so ndizingana. Ngori ndi maths 0 baneno. 03 or ndi 1503 or 1512.
Ngori.
What do you cut me? Hey, brother.
No, and it's 26. Your change and it's 26.
Hey, brother.
Yeah, and it's 26 as you know, it's okay. Carry. Ngornena ndo wango submit, mara ndo submit. Mbozungwa pasi zila za chincha. Tuko bona bundo.
Okay.
Tuko bona. Ndi chapter mine chapter 2.
Chapter 3. All right. Hapa ndani kwa tutacheza hizo ro cover 1 norm, ra cover 2 norm, ra cover infinity norm.
Tuko bona la watu.
Aziko bona la. All right. Nditozama ufungwa
Ndipo mnye bako bona na.
Amanda.
Yo, somebody the matanga.
No, nditongwara zvihulu nya. So those are the lessons we covered last week. So now, ndikotoda ureite the questions. Ngamanda record you ita questions zine
Oh, last week Thursday bovana class.
Yeah, Rovana class, record ne recorder. That's nothing.
I will look at it.
All right. So now ndiko ja question ineko baka tutorial later. Ineko toda ela information yenda inezwa zvino. So sajenda base questions dziva dzikodilana na dzi vector. Arichava ka matrix zvino. Ka matrix rido via later nyana. Musi rono cover dzi vector dzote. So now these are the vectors. So we are given vector u in this form. So some they use this kind of brackets, or you use the curly bracket, is the same thing. So we have 3, we have -1, and we have -2. And then the other one we are given
The A panel meaning.
the 3, -1, and the -2. And we are
Up and U or what?
the U. And this one is V. Of which is given as -1, 0, and a 2. And then the other vector is vector W, which is given as -6, 1, and 4. All right. First questions is not one upper. The first one is to calculate or to find the norm of U. Norm 1 of U, and norm 2 of U, and infinity norm of U. These are the 3 things that you're going to do. And then the second is to find the dot product of U and V. And then the third question is to find the cross product of U and V. So now let's start with the first question there, of which is about finding the one norm. The one norm of this.
Yo, at those are camera to na problem amato.
Oh.
Yeah, you do ba issue ka ene brother. Enti ko bona nga man. ukubona zikupetisana zikopenya
And it's too cool.
Amana
Oh,
ndokubona
Hapana tazana thanda kuzibona zona.
hezwi zwi khou vhonala
Dzi caution dzine ndi
Oh,
yeah.
hapana. So zwi amba uri ndi ḓo zama uri ndi tshi ṅwala solution ndi ite nthu. Ndi zwi ṅwale
Ba
zwi
ṅwale na caution.
roṱhe ti. Ndi ḓo ṅwala zwihulwane.
Zwa zwino vha khou vhona i khwine zwone vhondo
Da?
i khwine.
Oh, okay.
I khwine zwino.
Yeah. So ari thome ngo wana one norm ya u. Ri khou ḓo wana one norm ya u hafha. So one norm ya u ri wana ri khou shumisa formula ya uri one norm of u is equal to sum from I equal to 1 up to n of xi, where xi are the components of u. And here you can use the u to indicate all the components for the u. Right?
Yeah.
So that is the formula we are going to use. All right, let's use it and see what we obtain. We are going to have one norm of u is equal to, what this formula say is that we are going to take the positives of all these values that we have here, because we have these absolutes. Absolutes zichinja negative yaba positive. So now jamba jariko wana positive ya 3.
Absolute ain't only okay.
Absolute ziva zikhomba zvari arali rina negative value do chinja yaba positive. Roṱhe ti?
Yeah.
So jamba ri hapa ri ḓo vha 3 and then hapa ra vha 1 and then hapa ra vha 2. So after ro no wana the positive values of this, what do? We have to add all these values. We have to add all of them. So jamba jari rechi add in this case ri ḓo vha 3 plus 1 plus 2, of which this is equal to what? This is equal to 6. So now that is what is called the one norm of u. So now let's find the infinity norm. I left the root here. It must be inside the root like this. So it's the root of 6 like that. All right. Then now Areka and norm 2 norm of u. So 2 norm of u is given by this formula of root of summation from 1 to n of now we are no longer having the absolutes, but we are having the what? The square is ui squared, like that. So in other words, we are going to square the u's and then take the summation, and then from there we take the what? The root. Rewrote terms.
Yeah.
All right. So now let's do the 2 norm for this. We are going to square 3 here. What is the square of 3? What is the square of 3?
Oh, I asked 9.
Yes. And then the square of -1 is going to be 1. The square of -2 is going to be 4. And then after obtaining the squares of those values, we have to take the sum. We have to take the summation of all these values, and then we take the root. So it means we're going to have root of 9 plus 1 plus 4, of which is going to be root of 40. We have root of 40. Yes, root of 40. All right. Then after having that, we are going to the last one, which is infinity norm. What is the infinity norm? Infinity norm is the maximum. Is the maximum of these values, but is the maximum of the absolute of u. So let's check the maximum of absolute of U, and we see which values we are going to get. So it means in this case, we are taking the absolute of 3. Rote.
Yeah. Bondo.
Da.
Right.
All right. So record that idea absolute ya 3 in the 3. Right, absolute ya -1 in about 1. Right, absolute ya -2 in about 2. And then from there, if we record that infinity norm, jambo record that I choose in about kuranesa case values. So in our kuranesa, you will see, or in this case, it's going to be what? It's going to be 3. Therefore, infinity norm of U is going to be what? It's going to be the value 3. And that's how we're supposed to calculate this 1 norm, 2 norm, and infinity norm.
Bondo vari.
Many?
Apakah infinity tsina? Ritojia kuranesa tsi maximum.
Ridaraja
Ina
maximum.
abona ndi 3. Vana ina abona ndi 3.
All right. Rega question 2.
Hey, Bondo.
Da.
Yeah, network yanga na msiko kukorera ngam yova yombvisa out ndotobuya naona vachivomwara 3.
Oh, okay. Apaka kameni ka
Yosekori
infinity
ichivondova ichivonjoinisa yosekori chinjoinisa ndawana vachivomwara uri ansara ndi 3 yapo ka nomu ya infinity ubva vachikoita nomu 1 nomu 2 yova yombvisa yonra achivosekori arada vashinga ngaruviro rwuri vachingaita nomu to infinity 1 something na 3 na ya infinity vakotonawo vasokumwara vakotoamba ndivone kuti kuvodzitisa.
Okay. No, I wanna try it. I without chance. So arshom yapaka nomu ya infinity. So ka nomu ya infinity rikotoma ngodaraja zi absolute za 3 na absolute ya -1 na absolute ya -2. So absolute ya 3 ndi 3, absolute ya -1 ndi 1, absolute ya -2 ndi 2. And then from there, jambo require ra choose ya maximum hapo. Ndimsiri kuona infinity norm. Require choose value ya maximum kezi taru zera ziwa. The maximum ndi 3 in this case. So that's why I require infinity norm of U is going to be equal to 3. Because 3 is the highest between these 3 values we obtained there. Womnya? Hello? Womnya? Charles.
Hello,
oh, okay. Hey, yeah, network. I think it's bad.
That's how much combo network support.
Yeah. But all in all, this is how we're supposed to get infinity norm, and this is how we're supposed to get 2 norm, and this is how we're supposed to get 1 norm.
It's easy, no,
I didn't know. It's just a matter of remembering the formula, and then you will get all the norms.
Namara chapter 1 at 2 just strong.
Yeah.
But on that time.
No, till data revision. So Reka product it.
Reka's product.
Da. Rote.
Rote.
Awumnya izikusibiza network isikhoba favor namusa.
Ayikho dots.
Yeah, no, Reka product. But again, wako vanatize umsilifatuma dot product musibasi. But that is how we're supposed to get the norms. Jambori with the Dwanda Talushes and Alvaku Puri about the percent.
Machibu.
Womnya,
Tomnyaba. Yarisipanda na last week into Saturday.
Okay. So now we can dot product. Dot product is just a matter of putting a dot. Yes.
Dot product of U and V.
A is the dot product of U and V.
Okay.
So in secondary level, dot product, dot and cross are the same. But on this chapter, it's not the case. Dot and cross are not the same. Cross and multiplication. So these are not the same. So now if una dot it is this is what we do. This is how we multiply the two vectors with which are multiplied with a dot. So we have U negative, which is 3, -1 and -2, and the dot, and then the V, which is -1, 0, and 2. So from there, if we want to get the dot product of this, we have to multiply first component with first component. So first component times first component is going to be -3, and then we multiply second component with second component. So in this case, there are -1 and 0, of which if we multiply -1 and 0, we're going to get a 0. And then we multiply -2 and 2. When we multiply and 2, we're going to get a -4. So Jambo records the edits in the done again and -7. So -7 is the dot product of U and V. Raw terms. Yeah, that is how we're supposed to get the dot product of U and V. So once you understand this dot product of U and V, you can do the dot product for U and W, the dot product of V and W. So use the same strategy. Rieka cross producting.
Something.
All right.
Ondo.
Da.
Namsikonkorera.
Hey, andikubona zvone. Mara vodzipfesa zilazi nom.
Atangopa chitu. Ndovagaba vilo chomba vadote vile votomatungopa china chitimara sai.
Okay.
Did check out video somewhere right ezo rekasiye panda.
Yeah. So then hapaka cross product and ndakutarisha the first component imaplan first component. Second component yamaplan second component. Third component yamaplan third component. And then from there at the end, there we set the product here you know.
Okay.
Yeah. So G require cross product. So cross product you na V. Cross product you na V. So row your term either direction yeah, this new vector that you're going to get. So Jambos already I na J na K. And then second row equal U in there you know 3, -1 and -2. And then third row equal V in our -1, 0 and 2. So, and you can see this is just the determinant. We're going to get the determinant of this. So just by getting the determinant, we will now have the cross product of U and V. Raw terms. All right. So then now let's find the determinant of this. So determinant require a holder I. In a Richie holder I. Jambazori I equal holder first row and first column. Jambazori darasa
-1, -2, 0 and 2.
Raw 30. And then you're not going to tell it if you are negative. zvichikobva
Negative
kadzi
1, negative
Equal to-
2, 0, and
equal to j, negative j. So recall that this one and that one is okay. 3, negative 2, negative 1, and 2. Rottens.
Yeah.
All right. And then from there, I have K. In a K, recall the first row and the last column. So which means we're going to have 3, negative 1, negative 1, and 0. So Sarango multipliers. We're going to multiply these two. We multiply this with that, we subtract with the multiplication of this. So Zhinezhikorinam happened is 0, then rich multiply in the negative 2 I. And then on the other side, the j, this with that is going to give us 6, and then this with that is going to give us minus 2 plus k, and then there we're going to have 0, and then this we're going to have 1. And then from there, I add this like term. Remember, there is 2, negative 2i minus 4j, and then minus k. So that is the cross product that we're looking for. So it's the cross product of this. So whenever we are looking for cross product, we are going to get a new vector. But there's something which is very important that I would like to talk about this dot product and the cross product, because they're not just the symbols, they talk about something. So cross product here you na v, either perpendicular to the vector that you are going to get down there. So I've run a vector negative 2, negative 4, and negative 1. Then this vector I want to either perpendicular na vector u and v. Are we all together?
In which way? Gandila devondo bakuzamisana vachiri vai perpendicular.
Vector like in this line, a line in the ravanayo. Wako ubona penda faraka bottoms. All right. Let me take something and explain to you what I'm talking about. You see this box is in 3 dimensions. This box is in 3 dimensions, right?
Yeah.
Why we say it's in 3 dimensions? Because we have this line, which is perpendicular to that line going downwards, and which these two lines are perpendicular to that line that is going backwards. Rottens. So Gino, vector line here of vapor uyanke, equal represent a vector. Let's say is vector u. So this line is vector u, and the line that is going downwards, let's say is vector v. So if this is vector u and that is vector v, therefore the answer we obtain by multiplying these two, by finding the cross product of these two, is going to be the line that is going backward. Why? Because the line that is going backward is perpendicular to this line that is going to that direction, and the line that is going downwards.
Okay.
Yes. So the answer you obtained here is perpendicular to these two vectors that you have at all times. This does not change. Whenever you obtain the answer that is there, you are going to get the perpendicular vector. Because sometimes these guys, they confuse you by saying, find the perpendicular vector to u and v. So you must know if we are finding for the perpendicular vector, we have to do the cross product. Because question find the cross product, find the perpendicular vector. Rottens.
Okay, Evondo.
Da.
Richi anepa ndunyango divangedzi IJK ziraponta uri dzitova murayo no ridzive murayo no be IJK.
Yes, the direction. These are the directions of these vectors. So this vector is negative.
I for the zero
Network.
Marandu we actually are in the the ketchup. Okay.
Yeah,
Mondo.
that.
Panaka J, is it a minus? Ripanga the minus.
The minus, yeah,
Iri minus plus.
iri plus, minus, plus, minus.
So iri, no. Because when I found your minus J.
Apa non?
Apa lanta. Palanta iri means.
DJ. Ikore IJK.
Dukamba ngapa. See, like we're like in the one into the older first column and first row.
Yeah.
Then that one
exactly.
-1, -2. Then
Ah.
that K with that the K with JT. I'm gonna hold that column in the last na one. The minus, yes, I understand. The repala the minus J or what at one.
The minus J happen. The minus J.
Oh.
And then that tells us the IJK. These are common in this case. Because they indicate the direction of the solution you're going to obtain down there.
Somebody cheapers are A plus K.
Afanoni passive.
Makombola.
Or
Yes.
Plus K.
Yes. Okay.
So that's the number.
Then Richie multiplier. Huh? The Richie multiplier reaches an.
Multiplier 0 na 3. Then rawana 0. Multiplier -1 na -1.
0 na 3 na -1. Multiplier. Okay.
What a determinant.
Corner determinant. Corner determinant. Okay, that
so it's negative 2i.
Negative 2i minus 4j minus k.
And kambora palanta. Tapala.
Negative
2i, yes.
Minus j.
Yeah.
Into 6 minus 2.
6 minus 2. Why 6? Oh, okay. It's this and this and this and this. Okay. Plus k.
0 minus
0 minus 1.
Yeah, exactly. All right. So then now, Nakademba, I na J na kids. What's called Sumbeza direction. Yeah, a vector I wanna. So in endo notations uripinduro ya cross product at all time. Iba ipependekula na u na v. So zine arali rona wa u na v pinduliner do you wanna either ipependekula to these two. So that is the explanation I've given about the cross product, because question anga dori find the cross product inga dori find the perpendicular vector to u and v. So you must realize that if we are looking for the perpendicular vector to u and v, we're going to find the cross product raw terms. So zino ndo taluchedza nga cross product ndikoya ka dot product. So dot product nayo important zvinhu. Already record dota two vectors. Record dota vector u na vector v. Then dot product yarisvikisa kapinduro ya 0. So richi dota vector mbili dzarisvikisa kapinduro ya 0. Zviva zvikorevudza uri vector u na vector v, they are parallel to each other. Are we all together?
Yeah.
Dot product area with cousin dot u and v if they are equal to vector 0. Therefore, that simply tells us that u is parallel to vector v. So it's another important information which you must take note of. So the director's questions about this so that you can see what I'm talking about. So I believe you understood about these topics that you have covered here. Can we go to the next topic for the day?
Yes.
Yes. Of which is very important. This is about equation of a line. This is about equation of a line. So I know when I'm talking about equation of a line, what comes into your mind is the straight line formula. Y it is equal to mx plus c. This is the equation which comes into your mind when we are talking about equation of a line. But this is
Okay.
Yeah, okay. So this is the formula for the equation of a line. But for vectors, we don't use that formula. So I'm going to give you the formula that we use to calculate the equation of a line for vectors. Raw terms.
Yeah.
So this is the equation of a line for vectors. So we have R, which stands for vector, is equal to R naught, which is the vector at the origin, plus a lambda, which is a scalar quantity. So this is a constant. It's like a C. So it's a scalar quantity. A constant, we call it a scalar quantity. Let me write it here. So this is a scalar quantity. Scalar quantity. So, and then this scalar quantity we multiply with V. So this V is a vector. So this is just the coordinates, but this is a vector. Let me not write arrows here because the arrows they indicate that it's a vector. So, but this R naught is not a vector, but V that we are dealing with in this case is a vector. Raw terms. All right. Because of the example, let's say we are given points in 3 dimensions like this. This is a shape in 3 dimensions. So this is X and this is Y and that is Z. These are perpendicular to each other, like a Cartesian plane. X now Y direction. We know X and Y, they are what? They are perpendicular to each other. So, but in this case, Rina, 3 dimensions. So, Rina X dimension, Ravana Y dimension, Ravana Z dimension. These 3 dimensions, they are perpendicular to each other. So, Rino, Rina pointing, let's say Rina pointing 1, 2, and 3, and we have another point here of 2, 0, and 1. So normally from secondary we call these coordinates, né? So from the coordinates we must be able to find vectors. So like Sajenda Jiamba, A R not even a coordinate, A R not even coordinate, Mara V even a coordinate, V in the meaning the vector. So because of the culture, V re one is an R was coordinate. If a run our coordinating be vector one is any from coordinate. So this is how we're going to get a vector. So we're given 2 coordinates here. The first coordinate is 1, 2, 3. The second coordinate is 2, 0, 1. So in order for us to find the vector, of which this vector, I'm calling it vector V. So we have to subtract these 2. You either subtract from here to there or you start from there. The negative sign is not important because with the negative sign, you are going to get the scalar quantity. So in this case, recording 2 minus 1, comma 0 minus 2, comma 1 minus 3. Therefore, Jambo corner vector number 1
2 minus 1, comma 0 minus 2, comma.
So this is now a vector. It's no longer the coordinates, but it's what? It's a vector.
Bondo, what 1 minus 3? Bondo.
Yes.
Bongwar ba ko ba na palanta? Yo bongwar vho ṅwala
Eh.
vho ṅwala dzi value dziḽa dza nṱha thi khou dzi vhona.
Na 1 na 2 na 3 ravha na 2 na 0 na 1
ngori ndo vhona a khou ri 2 minus 1
ndi 2
hafha na
minus
nṱha ndi
1
1
hafha ndi 1
then 0 minus 2
0 minus 2
then 1